In the last video, we saw an introduction to why we need the binomial model, and it's a way to calculate probabilities when we just want to find what's the probability of seeing a certain number of successes out of a certain number of trials. Now, we had a nice kind of short example in that last video, but imagine we expanded the number of trials. And the larger the number of trials get, the harder that calculation by hand can be for certain problems. So instead, what we're going to do, and in the textbook, you'll see a formula for binomial probabilities, but we're just going to use Geogebra. Geogebra creates a really nice visual and will calculate the probabilities for us, so then we can just really worry about the interpretation of the probabilities. And then also, we'll talk about some instincts to what probabilities make sense for certain events. So the breakdown of notation that you're going to see for the binomial probability models, to define the model, we often use this notation here, where x is our random variable. X is representing the number of successes in a certain number of trials. The little squiggle there would be read as defined by. And then what we're saying is that this is a binomial model with a certain number of trials with this probability of success. So reading this as a sentence, how I would read it is our number of successes is defined by a binomial model where we have n trials and p is our probability of success. So instead of writing a sentence saying all of that, what we can do is summarize it with this notation here. The only thing I would adjust is I would put in a number for n and I would put in a number for p to define our specific model. So p is our probability of success, q is the opposite, it's a probability of failure, and then we're using x to represent the number of success and n trials. We have this idea of mean and standard deviation with the binomial model. You can calculate it, and to calculate it, you would just multiply your number of trials times your probability of success. Then for standard deviation, you take the square root of number of trials times your probability of success times your probability of failure. But what we're going to see is when we get into GeoGebra, it actually gives you both of those values. But if you need to calculate it by hand, that's how you would do it. Not too bad in terms of formulas. So what we're going to do is go through an example and how we can use GeoGebra to help get answers. When we get into GeoGebra, we're going to see something like this, and I'll tell you how to set this up. But let's talk about the example that we're going to work through, and then that can help make sense of what we're seeing from GeoGebra right there on our page. So, our example, we have a free thrower, and they're still making 82% of her baskets. We're assuming independence, so that probability isn't changing. And now what we're going to have is shooting 10 free throws. So in terms of our notation from up above, if we think about what n represents, that's our number of trials. In this case, it's going to be the 10 free throws. There's basically 10 chances for her to either make the basket or not make the basket. Probability of success is that 82%, which means the probability of failure, you just take 1 minus that, which is a 0.18. So we have those values for our setup. So then what we're going to go into is a bunch of probability questions, making exactly 5 free throws. We're going to look at the or case, 9 or 10 free throws. Thinking about a range of values, like at most 2 would look at like 0, 1, or 2 baskets. At least 7 would be 7's the smallest, so 7, 8, 9, or 10 baskets. And looking between 2 values, between 6 and 8 free throws. And then talking about our mean and standard deviation. So, with each of these, you can use the formula to calculate, but especially cases like when we get to this at least 7 free throws and you're trying to calculate the probability of making 7 or 8 or 9 or 10, you essentially have to use that formula 4 times, and that just gets very tedious. And what we want to do is instead is GeoGebra just has a nice little button that we can push and it'll calculate it for us. So, in terms of the setup of our problem and going into GeoGebra, we'll need our really 2 pieces of information. we're going to want to focus on the number of trials and our probability of success to set up our distribution. So what we're working with here is we could say our variables defined by a binomial distribution where we have 10 trials and a 0.82 probability of success. So that's just using the notation that we saw up above here to define our model. So let's see what's going on in GeoGebra and setting this up. So when we go to GeoGebra, you'll come to this home page here. Where we'll want to go is if you're at Classic Apps, you'll want to go down to Probability. So we worked with Spreadsheet before, but now we'll be working in Probability for a while. When you open up the Probability page, it's going to immediately show you this. There's our normal bell-shaped curve, and we'll be working with that in other sections in the course. What we want to do is change our model. We do not have a normal model here. Binomial is its own form of model. So instead what you want to do is go over here where there's a drop-down menu so you can see normal coming through. If you click the drop-down menu, all of these different options will show up. And what you can see is right there is our binomial model. So the first thing we'll need to do is change the type of model that we're working with. Once you change to the binomial model, it's always going to go to this kind of general form of 20 trials and a 0.5 probability of success. What we need to do with our problems is set up the model so it's specific to our example. So like we already looked at our question and we know we have 10 trials. So what you'll want to do is edit. So instead of 20 trials, we'll have 10. And then we can see as our number line change there. So now we're only seeing 0 to 10. And then our probability of success, we know that that is a 0.82. And we want to adjust that. So this is the model that we're working with. And that's what I copied onto our page here. So first thing you want to do, make sure you change to binomial mode there. Let's say that's step 1. Step 2, adjust N and P to set up our specific distribution from the wording of our problem. Then from there, it's going to depend on our question in terms of how we find our probabilities. So looking at this picture here, just looking at the graph, what they did is the height of the bars are relating to the probability of certain events. And if she's throwing 10 free throws and she has an 82% chance of making them, we would expect her to have a high number of baskets coming through. So the number line here is representing like it's 0. That's the idea that she makes 0 free throws, 1 free throw, 2 free throws, 3 free throws, so on and so forth across our 10 trials up to her making all 10 of the free throws. And what we can see is these bars on the higher end, we can see this kind of height to them, and they have a higher height because they have a higher probability of occurring. And then our probabilities decrease as we move to the left because she's so good at making 82% of the baskets. For her to miss all 10, basically impossible. So that's why we don't even see a bar there. It's the idea of a 0% chance. And even at 1 and 2, very low probability of occurring because she's so good. We don't expect those to come through, so it has a low probability. But then our probabilities start to decrease with what we expect to happen and the more likely events. So it's around 8 and 9 that we really expect her to land, and then from there it'll start decreasing because yes, there's a high chance that she'll make all 10, but not as high as her making 8 or 9. So that's what's being shown in the picture there. Then there are these different sections. On this right-hand side, this is listing the specific probabilities for each event. So this notation here is showing like what's the probability of, and then substituting in numbers for K. So like probability of making 3 baskets, there's a 0.04% chance of her making exactly 3 baskets. There's a 29.8% chance she makes exactly 8 baskets. So these probabilities on the right-hand side are for those cases where you're looking at exactly some number. So that actually links to our first example down here. In part A, what's the probability that she makes exactly 5 free throws? Well, if we're looking for probability of X, and then we want exactly, so it would just be equal to 5, that probability, we just look at our table and go to where 5 occurs, and the probability is right next to it. So a 0.0177. So there is a 1.77% chance she makes exactly 5 of the 10 free throws. We could even use that table for part B, saying what's the probability that she makes 9 or 10 free throws. So this would be the same thing as looking at the probability of her making 9 free throws plus the probability of her making 10 free throws. And from that table, what we can see is the probability of making 9 is that 0.3017 plus the probability of her making 10, which is the 0.1374. And then we would just add them, which would be a 0.4391. So there is a 43.91% chance she makes 9 or 10 of the 10 free throws. Then, when we get to these next ones, wording like at most and at least, those start to create areas under the curve. So the idea of at most, wording at most is always going to link to less than or equal to. So when I write this in my notation, I'm going to look for the probability that X is less than or equal to 2. Then the wording for at least links to the idea of more than or equal to. So if we want at least 7 free throws, we want to look at X more than or equal to 7. And then looking between two values, it's like X is going to be stuck between them. So this would be the probability that 6 is our lowest value for X and 8 is our highest value for X. So these are the 3 different cases that can come through, and GeoGebra has a special feature that lets us work really nicely with these 3 cases. And this is going to come through in GeoGebra right here. There's 3 options in that section there, and even if you're in GeoGebra, if you hover over with your mouse, you can see wording pop up. So it says left-sided, so what that's going to do is shade to the left-hand side. This is interval, and that's going to be the idea of between 2 values, and this is going to say right-sided because it's going to shade to the right-hand side. What these will link to is the left-sided case is for less than or equal to, or that idea of at most. This middle case is going to be the idea of between 2 values. And the right-sided case is going to be the more than or equal to side, and that's going to be when you see the wording of at least. So what you want to do is evaluate the wording of the question first and figure out, are you trying to look left-sided, right-sided, or in between 2 values? So for our first example there of looking for at most 2 free throws, what we'll be doing is this will be left-sided. So what we'll want to do is choose that option where the symbol looks like this. It's basically showing where your interval starts, and then it's going to get everything to the left-hand side of it. So we'll want to choose this button in GeoGebra, and then I'll show you where we can plug in this value of 2. So when we change to left-sided, so I'll go down here, select left-sided, what you'll see is my probability notation changed here. And what's nice is I'll keep writing the probability notation so you can see what you're plugging in where. So right now it's finding less than or equal to 6. And what's nice about GeoGebra 2 is that it shows this picture so you can see it's starting at 6 and shading everything to the left-hand side. What we want to do is adjust this, and there is a way you can kind of drag and drop, and that works fine for this binomial model. When we use normal model, you don't want to use this because the dragging feature isn't exact. It's better to get in the habit of editing. Edit your probability notation. So for us, we wanted at most 2. So what we do is delete the 6, plug in our 2. Just be sure to hit enter each time to make sure it all adjusts. And now we have our notation, and what's calculated on this right-hand side is our probability. Another cool feature is if you look on the right-hand side here, you can see the probabilities that they're adding up for us. So what happened is that all of these have a 0% chance of occurring, so when they were added up, it comes out to a 0. So with questions like this, figure out which side you need to shade, and then what you'll do is in GeoGebra, edit so that you're plugging in the number that we're working with, and then you can just copy the probability that it calculates for you. So there is close to 0% chance she makes at most 2 free throws. Let's throw in of the 10. It's good to throw in the number of trials, because if we change the number of trials, then the probability changes. This next case with D, probability of at least 7, so this is going to be right-sided. We want to find values larger than or equal to 7. So the button that we're going to choose is that one on the right that looks like this. So when we go to GeoGebra, we will change the direction, so it's on left-sided now. So now what we'll do is click the button for right-sided. And what it's doing right now is finding that probability of x is more than or equal to 0, so everything is shaded right now. And that's why we get a probability of 1, like there's a 100% chance of being in the sample space. And what we want to do is adjust that value to be 7. So this notation is a little different than what I wrote, but the meaning's the same. I mean, reading this, it says 7 is less than or equal to x. That's the same thing as saying x is more than or equal to 7. So the notation flips kind of here, but you still want to use the number that we're looking for. And what we'll see is this is a 0.9117, and then visually you can double check that it is finding the area that you want to. We do want this probability of being at 7 or larger. And what it's doing is it's adding those probabilities together for us. So that's a 0.9117. So there is a 91.17% chance she makes at least 7 of the 10 free throws. Then for part E, we're looking between 2 values. So we'll want to choose that button for looking between, or the button said interval. So we want to choose between, and then we want to set these bounds as 6 and 8. So we change our interval. So now you can see it's stuck between 2 values. So now you have a starting point and an ending point. And we just want to go from 6 to 8. And then you can see how it's shading. You can see on the right hand side what probabilities are being added together, and it's a 0.5395. So there is a 53.95% chance she makes between 6 and 8 of the 10 free throws. All right, then part D, expected number. So that's going to link to our mean, and then we want to know our standard deviation. So what we talked about at the beginning here is how we can calculate it. However, if you just copy, GeoGebra is always going to give you your mean and standard deviation in the upper left-hand corner, so you can just write those two values down from there. So we're going to have a mean of 8.2. And a standard deviation of 1.2149. And how this would translate into a sentence, and means our expected value, so that's what we expect her to do, and standard deviation tells us how we differ on average from that mean. So we expect her to make 8.2 of the 10 free throws. And on average, this will deviate by 1.2149 free throws. So it gives us an idea of what we expect, and then on average, how that will change. Now, so you can do with these, I just kind of leave it up to you. Here I use the exact numbers because that's what's calculated, and mathematically that's great. But if you start thinking about real world, like she can't make 8.2 baskets, it would make much more sense to use the number 8. Or then how it will deviate, like you can't have 1.2149 free throws, you could have 1 free throw. So for the wording here, feel free to adjust so that it makes more sense in context. Just be sure to approximate. So like we expect her to make about 8 of the 10 free throws, and on average this will deviate by about 1 free throw. So just be sure to adjust that wording if you decide to round.